What if I told you that there's a place in space where, if a living being ends up, it would die instantly? It would fall for a very long time and at the same time see the end of the universe. This isn't science fiction. These are real calculations. But the main question is, what would it feel in its final seconds? And would it even be able to understand that this is the end? The answer there might be much scarier than it seems.
The solar system isn't a very populated place, but compared to deep space, there's quite a bit of traffic here. Modern scientific understanding of the world around us suggests that out of the 8 planets, life exists only on Earth. What gives us the right to make such a claim? First of all, visual observations, although considering our relatively primitive technology, this is an unreliable source. I wonder what the inhabitants of other worlds would say if they observed our planet through a telescope or hovered in its orbit for a while. Would they be able to detect signs of life on Earth? Not necessarily. Hello, subscribe. But in some cases, we are almost 100% sure that certain planets or moons in the solar system are completely dead. And for that, it's not even necessary to land on their surface, like we did with Mars or the Moon. It's just that the conditions on such objects are so harsh that if life is possible there at all, it's most likely in the form of extremophiles, and the probability of that is quite negligible. Take Neptune, for example. This huge frozen ball has extremely harsh temperatures and hellish winds, so it's doubtful that anything could survive on it. Voyager 2, which flew by the planet in 1989, proved this convincingly. It even sent back documentary evidence. Do you want to hear the story of the most ambitious project from the early era of space exploration? Then focus all your attention and let's go. We won't cover the entire journey of Voyager 2 since its voyage is still ongoing. Contact with the probe is almost lost, but it is known for sure. If nothing knocks the probe off course, in 3 centuries, it will enter the Oort cloud, and in 296,000 years, it will encounter the legendary Sirius. But back then in August 1989, no one was thinking about such distant prospects. The probe had a clear and straightforward task: to fly past Neptune and gather as much information about it as possible. This was the last planet in the solar system that the probe was supposed to visit, and it did an excellent job flying over the celestial body's pole at just 3,000 kilometers. Earth's astronomers knew less about Neptune than about other objects in the solar system. This is quite understandable since the giant is located 4.5 billion kilometers from the Sun. Voyager 2 clarified many points and solved a large number of mysteries of the distant planet shrouded in a blue haze. The spacecraft started by taking a photo of Neptune on approach, which later went around the world. Before that, Voyager 2 had successively flown past all the gas giants: Jupiter, Saturn, and Uranus. The probe revealed things about the planet that scientists had no idea about. Almost 95% of what astronomers know about Neptune was obtained from Voyager 2. What did we know about the planet before that? First, a year on Neptune lasts 164 Earth years, and second, each season there lasts for 40 years. The rest was in the realm of guesses and hypotheses. So, what did the spacecraft see on the misty planet? The probe literally flooded Earth with scientific measurement data and images. For the first time, Neptune's rings were discovered, much more modest than Saturn's, but still quite clearly visible against the dimly lit planet. The spacecraft sent back to Earth photographs of 6 of Neptune's moons, among which Triton stands out in particular. This is what the gas giant looks like if you view it from the surface of this moon. The world also learned about Neptune's powerful magnetic field. It turned out that the magnetosphere stretches behind the planet like a tail hundreds of thousands of kilometers long. It also refined the length of the planet's day. A day there lasts about 16 hours. This figure was measured by the radio noise sent from the probe. Scientists knew that gas giants do not have a surface in the usual sense of the word. But what the layers of the planet are made of was not known for sure. before Voyager 2. The probe discovered an atmosphere above Neptune, which in itself is a paradox considering the extremely low surface temperature. The spacecraft found out that it consists of hydrogen, helium, and methane, and at the same time photographed clouds drifting above the planet. Just think, if you add oxygen and a lit fuse to this gas mixture, instead of Neptune, you would get a torch of incredible scale. But that's just a crazy thought. Do you think those are all the secrets that Voyager 2 discovered? Not even close. The most interesting part is just beginning. Despite the brief encounter, the probe learned quite a lot about the planet. And the first thing that sets Neptune apart from other objects in the solar system is its extremely complex weather conditions. Two monstrous hurricanes rage in the planet's atmosphere, called the Great Dark Spot and the Small Dark Spot. Voyager 2 captured both vortices. The first one has unimaginable characteristics from the perspective of Earthlings, and even surpasses Jupiter's Great Red Spot. The Great Dark Spot, first discovered and photographed up close by the probe, is an anticyclone measuring 13 by 6,000 kilometers, and it's quite comparable in size to Earth. It's a peculiar vortex in Neptune's cloud layer, and the winds inside it blow at supersonic speeds of 2,400 kilometers per hour. For us, speeds like that are rare even for jet aircraft. The Small Dark Spot, the second most intense storm. Until the hurricane disappeared in 1994, this figure was the largest in the solar system. Where does frozen Neptune, with a temperature of minus 221 degrees Celsius, get the energy to accelerate winds to such unimaginable speeds? That's a mystery that Voyager 2 left for us to solve. The probe's observation equipment also detected auroras at the planet's poles. In fact, they are several times stronger than those on Earth. Would you like to know what the last photo of Neptune, taken by Voyager 2 before it said goodbye, looked like? It's quite unusual. You might ask why the photo is so colorful. This way, the spacecraft tried to detect the methane haze that covers the planet with an invisible halo. Meanwhile, it presented scientists with a new mystery. They have yet to find out how sunlight scatters through the haze of methane. In any case, this image became the final one before the probe disappeared forever into interstellar space. Voyager 2 didn't make the 12-year journey from Cape Canaveral to giant Neptune for nothing. Otherwise, we would have missed out on so much about this unique planet, so unlike the other objects in the solar system. Now you will see 13 billion years on a 10-minute time scale. From the Big Bang to the present day, each second that passes equals 22 million years. On this scale, humans didn't exist until the very last fraction of a second. The universe will appear in 5, 4, 3, 2, 1. From the primordial cloud of gas and cosmic dust, gravity formed stars. Gravity bound star systems into enormous galaxies and guided them on their journey through the limitless cosmos. The relentless passage of time led to the evolution of the universe and created extraordinary wonders. Some galaxies formed so close to each other that they became entwined in gravitational embraces. What a magnificent sight that must have been. As it evolved, the universe went through different eras. Vast stretches of time with beginnings and ends marked by unique milestones, the appearance and disappearance of their wonders. We are the result of a great evolutionary sequence. A cosmic evolution we know very little about. The Milky Way. Gravity is the great creator, the builder of worlds. But gravity is also a destroyer because it is relentless. When a star with a mass of 50 suns dies, all the matter in its core collapses into an infinite black abyss, also known as a stellar mass black hole. The immense gravitational pull of these monsters is capable of tearing a star apart. They strip matter from the surface of the star and pull it toward themselves. This superheated matter orbits around the maw of the black hole, and huge streams of radiation jets shoot out from its center. Although these jets are visible throughout the cosmos, the center of the black hole remains a mystery. Even light cannot escape from there. That's why whatever is inside them is forever hidden from us. The death of a star and its rebirth. Throughout a star's life, there is a constant struggle between the force of pressure, trying to expand the star, and gravity compressing it. When a star runs out of fuel, it collapses and then explodes with the brightness of 1 billion suns. When a star explodes, it shoots into space all the elements it created during its life and death. These are new stars forming from the elements ejected during the explosion of supernovae. New stars are born from the remnants of dead stars. And it is precisely thanks to these processes of death and rebirth of stars that we came to exist. It happened in a nebula just like this one 5 billion years ago, where our sun was formed. A cloud of hydrogen was being compressed more and more by the force of gravity, and the life cycle of a new star began. A star was born, which would become known as the Sun. A system of planets formed around it. Among them was the Earth. Debris left over from the formation of the solar system collided with the Earth. The formation of the Moon. The young Earth was like a molten hell. The first continents were still forming. Volcanoes dominated the Earth, hostile and lifeless. But deep in the oceans, life began. According to the theory, substances erupting from underwater volcanoes solidified and created suitable conditions for the formation of the first cells. For about 3 billion years, simple microorganisms were the most advanced form of life on the planet. Cyanobacteria and other oxygen-producing microbes began to develop. They grew in colonies that released huge amounts of oxygen. The increase in oxygen levels became the key to the development of more complex forms of life. Organisms began to use oxygen for breathing. The development of more complex forms of life requires much more energy. Before complex organisms appeared, the planet experienced the longest ice age in its entire history. And then suddenly multicellular organisms began to appear. Before we start this episode, I'd like to offer a riddle to all our subscribers. Which planet is so light that it could float in a swimming pool? Which celestial body in the solar system is the most different from all the other planets? Here's a hint. This celestial body is named after the Roman god of agriculture. That's right, it's the majestic Saturn adorned with rings. Despite the vast distance of the sixth planet from Earth, research probes have been sent to it periodically. In particular, the interplanetary spacecraft Cassini studied these objects in great detail. It wandered through open space for 2 decades, closely observing Saturn and its moons. And this story began on October 15th, 1997 at Cape Canaveral. It was from there that the spacecraft carrying the Huygens lander was launched. The probe faced serious tasks, studying Saturn itself, its rings, its moons, and also organizing the descent of Huygens onto the planet's largest moon, Titan. Amazingly, the spacecraft brilliantly accomplished all its tasks. How many years did it take Cassini to reach its lifelong goal, ringed Saturn? For this, the spacecraft persistently covered mile after mile for a full 7 years, until on June 30, 2004, it entered the orbit of the giant planet. For many years, scientists around the world watched the station's activities with bated breath and marveled at the amazing discoveries it made. So what did Cassini discover on Saturn and in its surroundings? The probe took a close look at the planet's moons, sending images of previously unknown locations back to Earth. It literally plunged into the giant's icy rings and also studied the turbulent atmosphere, discovering an extraordinary hurricane at Saturn's pole, unlike anything else in the entire solar system. The probe's demise was no less spectacular than its life. In the end, scientists planned a series of probe flights between Saturn's rings, and believe me, it was a very risky maneuver. But despite the concerns, Cassini handled it brilliantly. Among other things, the probe was assigned one more task, and it was a sad mission. What exactly was it? Cassini had to sacrifice itself to avoid contaminating Saturn's moons with a possible crash, where, according to some astronomers, certain forms of life might develop. And this concerns not only Enceladus with its subsurface ocean. In other words, Cassini's life cycle was very eventful and colorful, and the probe maintained contact with scientists on Earth until the very end. So, what is this mission famous for? Which interplanetary traveler did the spacecraft encounter, and where did it meet its end? All of this will be discussed next. Thanks to Cassini, we have greatly expanded our knowledge of Saturn's rings. In past centuries, people spoke of them in the singular because it was believed to be a single band floating around the planet. This was mentioned in particular by Christian Huygens, whose name was later given to the lander that was part of the Cassini spacecraft. The rings of Saturn were first discovered by Galileo Galilei in the 17th century, and since then scientists have entertained all sorts of ideas about this strange formation. However, we have digressed from the mission of the legendary spacecraft. Thanks to Cassini, many myths were dispelled, as astronomers found out that the rings are made up of icy particles of various sizes, with admixtures of dust and organic compounds. There are 4 rings, and the last one is thinner than the others. Their diameter is enormous. It's about 250,000 kilometers, while the thickness of the formation doesn't even reach 1,000 meters. Moreover, it is extremely uneven. In many places, there are voids or peculiar mountains made up of piles of rocks and ice. The amount of material in the rings is so insignificant that if all the rocky and icy chunks were gathered into a single mass, its diameter would not even exceed 100 kilometers. But this parameter can change if other space objects intrude into this stable conglomerate, for example, passing comets. Cassini also studied Saturn's moons, and there turned out to be 82 of them. Some astronomers compare the Saturn system to the solar system, where the rings symbolize asteroid belts. Isn't that an original analogy? Imagine how essentially a fragile piece of metal named Cassini, packed with equipment, rushes at a speed of more than 120,000 kilometers per hour, hurrying toward its final destination, the enormous hazy gas giant Saturn. Do you think we're describing the direct flight to the giant planet? No, that's what the probe's death in Saturn's atmosphere looked like. That's exactly the fate scientists had in store for it, or rather, were forced to give it. But before its demise, the probe still had a lot to explore, so let's not get ahead of ourselves. After its arrival in 2004, Cassini became the first artificial satellite of the gas giant, orbiting it at a speed of 15 kilometers per second. During this time, it approached many moons, such as the snow-white Enceladus, the mysterious Titan, and others. What was the most surprising discovery during the interplanetary spacecraft's mission? That is, without a doubt, Saturn's legendary hexagon, a giant stable hurricane located at the planet's north pole. Its diameter is 25,000 kilometers, so the storm could easily engulf several celestial bodies, like Earth. Cassini found that the vortex literally extends about 100 kilometers deep into the planet's atmosphere. To be fair, the hexagon was first noticed by the Voyagers, but due to the extremely poor quality of the images, no one paid much attention to this structure. Cassini who was the first to photograph this extraordinary storm from a distance of more than 2 million kilometers, showed the whole world that we are dealing with a hurricane of planetary scale and tremendous power. At the same time, the probe discovered that unlike the stable shape of the vortex, its color depended on the season and changed from bluish to golden. By the way, on Saturn, autumn replaces summer, then turns into winter and then into spring, following the same principle as on Earth. This is due to the tilt of the poles. When the northern part of the planet receives more sunlight, the hurricane, infused with the rays of our star, acquires a golden halo. In winter, accordingly, the storm becomes dark blue. How do scientists explain the appearance of the Titanic hexagon? Most likely it was caused by the movement of atmospheric masses during Saturn's rapid rotation. But what about the spectacular demise of Cassini? Did it bring any benefit to science? Yes, and a huge one. Returning to the hexagonal vortex, it's worth mentioning that the spacecraft photographed it once again as the probe's mission was coming to an end. It also discovered that it rains rocks on Saturn, triggered by the ongoing destruction of the planet's rings. When particles of dust and ice enter the giant's atmosphere, despite the considerable distance, this happens regularly. They break up into small fragments, so tons of ice and rocks fall onto Saturn every second. No umbrella can protect you from such a refreshing shower. What does this mean for Saturn's rings? Obviously, if the situation doesn't change, the planet will soon lose this distinctive feature. And it doesn't matter that the rings contain particles up to 100 meters in diameter. They too can eventually break apart. I wonder, what are the reasons for this strange phenomenon? It turns out that the ice particles have a permanent charge, and Saturn's core is surrounded by so-called metallic hydrogen, which generates the planet's magnetic field. Both structures are attracted to each other, like hair to a thoroughly rubbed balloon. That's why the rings are being destroyed, gradually giving their particles to the planet. There is a mystery that Cassini managed to solve only at the end of its mission. Yes, and that's the age of the rings. Astronomers wondered for a long time whether they are younger than the planet or formed alongside it. It turned out that the age of the rings ranges from 10 to 100 million years, which means that during the time when life was emerging on Earth, Saturn didn't have this adornment. These conclusions were made by scientists after obtaining data on the size and brightness of these objects. If the rings were older, their brightness would have significantly decreased due to the systematic accumulation of space debris. By the way, one of the theories about the origin of the rings is the hypothesis that Saturn attracted a large icy moon. As a result, the giant planet simply tore the object into small fragments. To Cassini's credit, it's worth remembering that even as it perished in Saturn's poisonous atmosphere, it continued to carry out its mission and was able to capture images of the gas giant's clouds from the closest possible distance. Thanks to this tiny yet persistent and fearless probe, we got to know the enormous and distant Saturn much better. Through the probe's eyes, we saw a monstrous vortex, learned about strange rock rains, and also observed the planet's moons and rings, uncovering some of their mysteries along the way. Meanwhile, Saturn continues to rotate in the company of Tethys, Iapetus, Mimas, and Enceladus, Titan, and other celestial bodies that naturally accompany it. It is quite likely that another 100 missions will be sent to the giant planet, and perhaps our descendants will even spend their vacations in its orbit. But Cassini's achievements will still not be overshadowed by that. If you enjoyed the video, we invite you to subscribe to our channel and give the video a like. And on our part, we promise to create even more interesting content about the amazing things hidden in the depths of our universe. Take a look at the screenshots that are on the screen right now. These are statistics from YouTube. What does it mean? Notice that right now, 57 viewers of this channel are watching without subscribing. This is the true essence of my message to you. Therefore, so you don't miss Hubble among your subscriptions, all you need to do is click on this red button. which looks like this and is located below this video. The law of the universe is simple. Remember that. After all, every subscription from you is very important to me. The more viewers there are, the more often they watch and like, the faster a new super exciting video comes out. Talk to you soon.